viewers, in last lecture we have seen what are the criteria for designing a synchronization solution. So starting with the first solution or the first synchronization mechanism, as there are three mechanisms I have already told you about, that is locking, semaphores and Peterson solutions. So we'll talk about the first mechanism, that is locking. Now under locking there are two types of locking mechanisms design. First one is with the help of lock variable and the second one is with the help of test and set lock. Now talking about the first mechanism, which is a lock variable, so let us look at the basic characteristics of this lock variable mechanism. So mainly it is based on busy waiting solution. That means particular process is busy in waiting for something to happen. So the first characteristic is it is based on busy waiting solution. It is a software mechanism, that means nothing to do with hardware. The mechanism has nothing to do with hardware part, and it is implemented by user mode. So nothing to do with kernel mode. Obviously no assistance or help taken from operating systems. So what three characteristics of lock variables are mentioned here? The first one is it is based on busy waiting solution. It is a software mechanism and it is implemented in user mode. Most importantly, as we are talking about multi-process system, so that is cooperative processes we are handling here. So this is applicable for more than two processes. Those are accessing critical section. So those are mentioned it here. It can be used for any number of processes. It is a software mechanism implemented in user mode. No support required from operating system, and it is a busy waiting solution which keeps the CPU busy when the process is actually waiting. So it does not fulfill any criteria of synchronization mechanism. This is one a drawback of lock variable mechanism. We'll see in detail afterwards. So talking about the details of lock variable, so it uses a simple variable named lock. So initially the value of this lock is set to 0. When lock value is set to 0 means the critical section is currently vacant and no process is present inside it. And when lock value is 1, it means critical section is currently occupied and a process is present inside it. So how it is used? So as you can see at the left hand side, there is some pseudocode written, while lock not equal to 0, lock equal to 1 in critical section, lock equal to 0 non-critical section. So talking about this, the implementation deals with a simple lock variable which is initialized to 0. It means that there is no process inside a critical section, and if number of processes are there in queue, any process which finds lock 0 can directly enter into the critical section, and once it enters into the critical section, it can change the value of lock to 0. Now if lock is equal to 0, process stops at intersection only. That means if a particular process is trying to enter into the critical section by executing while lock not equal to 0 statement, and it finds that lock is set to 1, process has to stop at the intersection, and it confirms that any other process is already using it. For example, suppose there are two processes P1 and P2, and initially lock is set to 0. P1 finds that value of lock is 0. Then as value of lock is 0, it has a chance to enter into the critical section. It executes the first line, that is a while, amongst the three lines written at the left hand side, while lock not equal to 0. The first line is given to process 1. So now it executes the while line. So as lock is equal to 0, this line will be a false, right? So while condition becomes false, and it will come out of the loop. Now here how the loop is mentioned, while lock is not equal to 0, a semicolon is given. That means there is nothing written inside a body of while loop. That means when this condition get fail, it automatically comes out to the next line, which is nothing but lock is equal to 1. That is, when while condition false, it comes out of the loop and executes lock is equal to 1 statements and enter into the critical section. So what is the scene now? Process P1 finds lock value is equal to 0 and while condition gets fail, that's why lock value set to 1 and P1 gets a chance to enter into the critical section. Now P2, which comes later, tries to execute line 1 as lock is set to 1 by process 1 while condition gets true. As there is no body of loop specified, again it will keep on executing the same line till it becomes false. That is, P2 will be busy waiting for log variable to get its value that is equal to 0. That is called as busy waiting. Okay, so that's why the log variable has a characteristics busy waiting solution. It is a busy waiting solution. Now this is about how a log variable is implemented with the help of while loop and log value set to 1 or 0. Now talking about the drawback of this log variable, for that we need to go into the details how it is getting executed at the background. Now let us look at the right side of the slides where some assembly language set statements are given. So whatever left hand side code snippet is given while statement, this can be represented in assembly language statement at the right hand side. While log not equal to 0, we can map it as at the background whatever log value contains those are loaded into some CPU register. Then it is compared with the register contents are compared with value 0. If it is not equal to 0, then it will go back and run again the first state, that is load R1 is equal to log. So if it is 0, that means the comparison is false, then it will store 1 as log value and it enters into the critical section. Now what is the drawback? Now here it is possible that the scheduler or the operating system has a scheduler part which will preempt the processes. That means in between two processes P1 and P2, P2 starts executing it because initially it finds log it equal to 0. So it will execute the first assembly line, that is load R1 comma contents of log. That means P1 forces R1 is equal to the contents of log. Then it goes into the second line, that is compare R1 comma 0. Now when it finishes these two lines, now it is a chance of P1 to store 1 to the log variable. But due to preemption by the scheduler, P2 comes into the picture and simultaneously P1 goes into the hold state and P2 enters and it executes load R1 comma log. And again it completes the second statement, compare R1 comma 0. So now at the point when preemption is done, after some time again P1 gets its chance. That is, after P2 completes first two lines and already P1 has completed its first two lines. So but when P1 completed first two lines, it stores value of log is equal to 1. That means initially log is equal to 1. This is done by process P1 and due to preemption P1 goes into the hold state and P2 again wish to change, that is again it is going to execute the line store log comma 1. That means again whatever log ka value is, that will be changed to 1 by P2. That means value of log that was 0 at initially will be changed to 1 at the first step by P1. At second time, the value of log which was changed to 1 by P1 was again changed to 1 by P2. That means log variable is having a value 1 currently, but it is not specified that the operating system or the processor cannot get that by which process the log value is changed to 1, and both are trying to enter into the critical section. So this is totally against our first criteria, that is mutual exclusion. Every process should get a chance, and at a one amount of time only one process should be there in a critical section. That's why the log variable mechanism is totally dissatisfying the first criteria, which one is a basic criteria, mutual exclusion, and that is due to preemption. So what is the remedy for that. So to remove this drawback of lock variable, the advancement is done, and that is called as test and set lock instruction. So now this is instruction which is close to assembly language program. That's why it takes some hardware help. So what exactly it is doing? It uses test and set instruction to provide synchronization among the processes. Now I have separated it into the flows, that is assembly language flows. We have already seen what is flow in lock variable. Now we'll map it into the TSL, that is test and set lock. So here the sequence is given: load R1 at the left hand side, flow in lock, the load R1 comma lock, compare R1 comma 0, Z and Z, step 1, store lock 1, right? So due to preemption, the mutual exclusion gets dissatisfied. So if I wish to change the sequence of these instructions, I tried not many things here. The experimentation has done on this particular flow and checked that even if by changing the sequence of these instructions in lock variable, due to preemption, the mutual exclusion cannot be satisfied. So what is done here? To avoid it, they have changed the sequence and then combined some instructions together in one line to design a single instruction, that is nothing but test and set lock. So here the fourth line from lock flow, that is store lock comma 1, is taken as the second line, and the first two lines are combined together to design one single instruction, that is nothing but TSL. So you can see the difference here. In the flow in log, the sequence was explained earlier. Now in flow in TSL, the fourth instruction is taken here as a second instruction, and load R1 comma lock and is immediately followed by store lock comma 1, and these two are combined, that is as a part of single instruction. As single execution, the lock variable contents are taken into the CPU register, and simultaneously the contents of lock are changed to 1. So what is done next? Suppose process P1 comes into the picture and initially lock value is 0. So lock value, the first line suggests that load R1 comma lock. That means now contents of register will be 0 here, and immediately at the same time when it is sent to R1, automatically the value 1 is pushed into the lock variable. So this is done simultaneously by process P1. Okay, so P1 goes into the compare statement. Now if preemption occurs, and P2 comes, so what exactly it is doing? Already lock variable is 1 here because of P1. So it cannot go into as lock variable while statement is written, that check it right, that is compare R1 comma 0. So P2 cannot enter into the critical section. So automatically, immediately before comparison, automatically it is changed to 1 by ISL instruction. So the difference between lock variable and TSL is, in earlier mechanism, due to preemption, mutual exclusion cannot be satisfied because testing value of lock and setting new value to lock variable are done in different lines. But here those are combined together, and thus the mutual exclusion can be achieved, and at a time one process can enter into the critical section. Now what are the things here? Talking about their characteristics. So for characteristics, it satisfies mutual exclusion, but it requires special support from operating system, from hardware, and it should able to provide TSL instruction into this. That is, for execution of TSL instruction, it should take some support from operating system and underlying hardware. That's why it is not a totally software based solution, but it also takes a help of hardware or the underneath operating system. That's why it is not satisfying the fourth criteria of synchronization mechanism, that is architectural neutral. So it is not architectural neutral. So it ensures mutual exclusion. It is deadlock free. We'll see what deadlock is, but it is deadlock free. It does not guarantee bounded wetting. It may cause starvation. So why starvation? This is because a spin lock. So it is suffering from spin lock. So drawback of this test set lock variable mechanism is it is suffering from spin lock, and that's why it does not guarantee bounded weight and may cause sometimes a starvation. So looking at how it is implemented, the lines of ports are, there are two separate lines where they are for testing, that is lock not equal to 0, then lock is equal to 1. Two separate lines are given in lock variable mechanism. Here in single line they are giving while test and set is an instruction given one variable which will handle our lock part, and then it enters into the critical section. So here test set instruction with some variable returns a boolean value. At the background how it is written, it returns some boolean value. So just go through it. Boolean at the background, what exactly test instruction is, it returns some boolean value either true or false. Whatever I value is, if I is equal to 0, it makes I is equal to 1 automatically and returns true value. If it is not equal to 0, it will return simply false. So just go through the code snippet explained here. Just map it with the boolean, how it returns value true or false and how it gets executed. It is explained here. So the only process that can enter its critical section is the one that finds, here bolt is used as a lock variable. So here the only process that can enter its critical section is the one that finds bolt is equal to 0. Now talking about the characteristics, it is mentioned that it suffers from spin lock. So what exactly spin lock is? It is also called as priority inversion. So we know there are different scheduling algorithms are present in which a priority scheduling is also present. That means particular process is executing, and if some other process comes which has higher priority, then CPU will give a chance to that process, right? So based on that concept, assuming P1, there are two processes P1 and P2. Assuming P1 is in critical section, now there is new process P2 with higher priority comes into the picture and it wants to enter into critical section. Now P1 gets preempted. Assume P1 gets preempted because of a scheduler tries to run P2 first. That is, some scheduling algorithm is running at the background. Suppose priority scheduling is then there. P1 is already entered into critical section, and just it enters into critical section. At the same time, priority scheduler gives the priority to P2. So what should be done? As P2 gets the higher priority, it should be preempted. That means P1 should go into the hold state and P2 should get the chance. Now if P2 should get the chance, that means it should go into the critical section as well to complete its task. But P1 is already there inside a critical section and it is using test set logic to enter into the critical section. Now this synchronization mechanism will be stopping P2 because it is not dealing with the scheduler about its priority, and P1 won't let P2 to enter into the critical section because it is already there. It is not going to change the sequence. That is, once particular process enters into the critical section, it will not allow any other process to enter into the critical section even if it is of higher priority. Now P2 has to wait till P1 finishes its work, right? So now the scene is P1 is in critical section, P2 is having higher priority. Scheduler suggests P2 to go into the critical section, but due to synchronization mechanism, P1 is not allowing P2 to come into the critical section. So P2 is waiting for some time. That is, P1 won't let P2 to enter into the critical section till it leaves the critical section, and P2 wants CPU to finish it or come out from the critical section. That is, P2 wants to force it to come out of the critical section to get his own chance. So by the time P2 won't leave CPU, that is, till P1 is in critical section, P2 won't leave CPU. Hence P1 and P2 are both in a kind of lock. That is, for execution CPU is needed. For execution P1 needs CPU, and for execution P2 needs critical section. So the progress of both of the processes will be affected, and they are entering into a kind of log that is called as a spin log or a priority inversion. There are two concepts I explained just now, the new concepts. One is a priority inversion, that is also called as a spin log. So this is happening because of test and set log variable mechanism. So just go through it and try to understand what is the difference between log and TSL, what is priority inversion, what is spin log, what are the advantages and disadvantages of both of the mechanisms here, log variable mechanisms, and just go through the code snippet that is given here, that is test set, how it is executed, and um, try to write a program based on this. Thank you, girls.